Welcome to this video, and in this video I'm going to be breaking stoichiometry down bit by bit. Now I want you to know that in this video I'm going to cover all the basic and essence of stoichiometry. So I want you to pay rapt attention as I'll start my explanation. So let's start. Now in stoichiometry, you need to understand what we call the mole concept. And what is the mole concept? The mole concept has to do with number of moles. All right. So number of moles have different formula and is represented by n. So one of the formulas is number of mole equals to mass of a substance over molar mass. All right. Another formula is volume at STP over molar volume. Another formula is concentration times volume. But if this volume is in centimeter cube, then you have to convert it. So you say CV over 1000. Another formula for number of mole that you must know is number of particles over Avogadro's constant. And Avogadro's constant in chemistry is 6.02 times 10 raised to power 23. So these formulas, all these formulas that you can see here, they are very important as far as stoichiometry is concerned. All right. Now, let's get into more concepts already. Now, in more concepts, you realize that when a chemical reaction occurs, they occur in a particular whole number ratio. For instance, when C reacts with when carbon bonds in oxygen or reacts with oxygen to produce CO2, you realize that this chemical formula is balanced because this is C, this is C, this is O2, this is O2. And this balanced chemical formula is based on the law of conservation of mass. As atom can neither be created nor destroyed. So if one atom of carbon is here, in the compound there, one atom of carbon is also here. This is two atoms of oxygen or one molecule of oxygen. Two atoms equals to one molecule because oxygen occurs as O2. So this is two atoms of oxygen, this is two atoms of oxygen. So this equation is balanced like this. All right. So this equation is balanced. So it is very, very important to do a stoichiometric analysis based on a balanced chemical equation. And what would that stoichiometric analysis be? This carbon is one mole because nothing is written here, so it's like one carbon. Are you with me? And this O2, which is oxygen molecule, is like also like one mole because nothing is at the back of it. So you say one mole of carbon atom reacts with one mole of oxygen molecule. Are you with me? So mole is the coefficient. There's nothing at the back, there's nothing at the back. So here too, there's nothing at the back of this compound. So we'll give 1 mole of CO2. Are you with me now? Another way to put it is, you see this 1 mole equals to mass over molar mass. And the atomic mass of carbon is 12. The atomic mass of oxygen is 16. So we can do this this is in terms of mole, right? We can also do it in terms of mass based on this stoichiometry. All right. So we can say number of mole is mass over molar mass, right? N equals to mass over molar mass. So for carbon, 1 mole it will be 1 equals to mass over 12. So meaning that the mass of a substance, the mass of 1 mole of a substance will be equal to the atomic mass. So if you cross multiply, M will also be 12 here. Are you getting me? M will still be 12 grams. So you can say 12 grams of carbon react with O2 is 16 times 2. So molar mass of O2 will be, molar mass for oxygen will be 32 like that, 16 times 2. So if you do 1 equals to m over 32, by the time you cross multiply, your mass will also be 32 grams. So react with 32 grams to give, if you do CO2, that's 12 plus 32, give you 44. So it gives 44 grams of CO2. So in the question, what they will now tell you is that they will now give you a parameter. They can say how many mole of oxygen or how many gram of oxygen will be required to react with maybe 6 grams of carbon. So in that case, you will take this as your first or stoichiometric. This will be your stoichiometric analysis. Then you now use whatever they give you in the next part as your given. Then you now equate them together. And I'm about to do that now. So stay tuned.